In this illustration, we'll discuss a situation where we analyze particles' velocity in a parabolic motion. We are given that a particle moves in xy plane at constant acceleration f, which acts in minus y direction, and the equation of trajectory of particle in the given system is given as y is ax minus bx square, where a and b are positive constants, and we are required to find particles' velocity at the origin of the system. Now here we can write in solution the trajectory of particle is, here we are given the trajectory of particle as y is ax minus bx square. And in this situation here, if we differentiate it with respect to time, you can see we are getting dy by dt is a dx by dt minus this 2bx dx by dt. Here dy by dt is the particle's velocity in y direction and dx by dt is its velocity in x direction. So if we once again differentiate, this will give us d square y by dt square, which is acceleration in y direction. On differentiating this, we are getting it as a d square x by dt square, which is acceleration in x direction, which we can ignore as we are given that the particle only has acceleration in minus y direction. That means the value of this ay is equals to minus f and ax is 0. But let's first complete it. So here this 2b multiplied by, if we differentiate it, x dx by dt, then here we can write 2b, when we differentiate x, this will be dx by dt, so this is dx by dt whole square, minus, if we keep x as constant, this 2bx, and derivative of dx by dt is d square x by dt square. Here these two terms we can ignore as d square x by dt square is equals to 0. And this is the velocity of particle in x direction. So here we can write minus f is equals to minus 2b velocity in x direction square. So here we are getting the value of a speed of particle in x direction, which is root of f by 2b. And we are required to find the initial speed of particle, which is root of ux square plus uy square. From this expression, you can directly calculate the value of particle's velocity in y direction at t equal to 0, which you can see what we are getting here. This a dx by dt is ux, which we already written as f by 2b. And at x equals to 0, here this term will vanish. So here we can write it a multiplied by ux, which is root of f by 2b. If we substitute the values over here, you can see the initial speed of particle we are getting is root of ux square is f by 2b, plus if we square the velocity in y direction, this is a square f by 2b. So you can see if we take this f by 2b common out, the result we are getting is root of f by 2b multiplied by a square plus 1. That is the final answer of this problem. And the same problem can be easily handled in an alternative way directly also. Here you can see, if we talk about an alternative solution of the problem, here this can be handled if we compare this equation of trajectory, which you can see a quadratic term, which is a parabolic expression. If we compare this term with y is equals to x tan theta minus gx square by 2u square cos square theta, which is the equation of trajectory of projectile motion. Then on comparing these two equations, if this 1, this 2, here we can write from 1 and 2, we are getting the value of a is equals to tan theta and the value of b is equals to this g by 2u square, and here 1 by cos square theta I can write as sec square theta, which is 1 plus tan square theta. Now in this situation, if we combine the two and eliminating tan theta, we calculate the value of u. You're getting the same result, u as root of f by 2b a square plus 1, which is the answer for the problem. And you can see by comparing the parabolic trajectory with the equation of trajectory, we are directly getting the same result which we have evaluated by the traditional method of differentiation.